Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. Lecture number 7 of the chapter Lines and Angles, class 9th, subject Mathematics. And our today's topic will be relation between angles and particularly alternate exterior angles and co-interior angles. We have already discussed about some relations between angles, such as a linear pair of angles, vertically opposite angles, and alternate interior angles, and another one was there, that was corresponding angles. We have discussed 4 out of 6: linear pair of angles, vertically opposite angles, corresponding angles, and alternate interior angles. Now in today's lecture there will be discussion about the alternate exterior angles and co-interior angles. Let's take alternate exterior angles and see which angles are alternate exterior angles and what is their relation. If you see alternate exterior angles, that means outside line L and outside line M. We have angle 1, angle 2, angle 7 and angle 8. These are exterior angles. Angle 1 is on the exterior side of this line L. Angle 2 is also on the exterior side of this line L. Similarly, angle 7 is on the exterior side of line M, and angle 8 is on the exterior side of line M. So we have exterior angles is angle 1, 2, 7 and 8. Now, alternate. Alternate means if this line we call as transversal or intersecting line is line M. We will take one exterior angle. Suppose we will take angle 1. This is an exterior angle. We are taking angle 1. And now with this angle 1 we are going to take another angle, that is angle 7. See, angle 7 is an exterior angle, angle 1 is an exterior angle, but angle 1 is on the left side. Angle 1 is on the left side of this transversal, and angle 7 is on the right side of the transversal, although both are exterior angles. Angle 1 and angle 7 are exterior angles, but angle 1 is on the left side of this transversal and angle 7 is on the right side of this transversal. So these angles are called as alternate exterior angles. Which angles? Angle 1 and angle 7. Angle 1 and angle 7. Angle 1 and angle 7. Although these are exterior angles, but these are alternate exterior angles. Similarly, we have angle 2, that is on the right side of the transversal, and we have angle 8, that is on the left side of the transversal. Although these are exterior angles, angle 2 and angle 8 are exterior angles, but one is on the right side of the transversal and another angle is on the left side of the transversal. So we take them as alternate exterior angles, angle 2 and angle 8. So we have two pairs of alternate exterior angles. One is angle 1 and angle 7. Second pair of alternate exterior angles is angle 2 and angle 8. Now, are these angles equal? And is angle 1 equal to angle 7? Is angle 1 equal to angle 7? Yes, angle 1 is equal to angle 7. Yes, these are alternate exterior angles. Yes, these are alternate exterior angles, but these are equal. Why? Why these are equal? Why are alternate exterior angles equal? Because the intersected lines, that's L line L and line M, these are parallel. When these are parallel, alternate exterior angles are equal. If these two lines are not parallel, then these alternate exterior angles will not be equal. So it depends upon whether the intersected lines are parallel. Here, these intersected lines are parallel, therefore we can say that angle 1 is equal to angle 7. Similarly, we have angle 2 is equal to angle 8. These are alternate exterior angles. Okay, now we will talk about co-interior angles. Interior angles. Let us first see which angles are interior angles. Angle 3, angle 4, angle 5, and angle 6. These are interior angles. These four. Angle 1, 2, 7, 8 are exterior angles, as we have already discussed about them. Now we have angle 3, angle 4, angle 5, angle 6. These are interior angles. Interior angles. Now, which of them are co-interior angles? Now, co-interior angles are angle 4 and angle 5. Angle 4 and angle 5. These are interior angles, but these are co-interior angles because these are on the same side of the transversal. This is a transversal. Line M is a transversal, and angle 4 is on the left side of this transversal, and angle 5 is also on the left side of this transversal, and hence these are called as co-interior angles because these are interior angles and these are on the same side of the transversal. Angle 4 and angle 5. These are co-interior angles. Similarly, angle 3 and angle 6. Angle 3 and angle 6. Because these are, first, these are interior angles, and second, these are on the same side of the transversal. See, angle 3 is on the right side of the transversal, angle 6 is on the right side of the transversal. They are on the same side of the transversal, isn't it? And these are interior angles as well. So these angles are called as co-interior angles. So we have one pair, angle 4 and angle 5, co-interior angles, and another pair of co-interior angles is angle 3 and angle 6. Now one thing is there, that is, if we add these angles, if we join these angles, that means angle 4 and angle 5, that is a pair of co-interior angles, it has been found that their sum is always equal to 180 degree. Pair of co-interior angles, sum of a pair of co-interior angles is always 180. So we can say that angle 4 plus angle 5, their sum is 180 degree. Pair of co-interior angles, their sum is 180. Another pair is angle 3 and angle 6. Angle 3 and angle 6, their sum is also equal to angle 3 and angle 6. Their sum is also equal to 180 degree. So sum of co-interior angles is 180. So this ends our relations between angles, but now we are going to use them in solving the problem, which is here. The problem is here. See, I will draw first the two lines, okay, but parallel lines. Okay, I am taking these as parallel lines, line L and line M, and we have an intersecting line that's called as transversal, line N. 8 angles are formed, we all know, and I am naming them as angle 1, angle 2, angle 3, angle 4. This is angle 5, this is angle 6, this is angle 7, and this one is angle 8. So we have 8 angles here, and if we know only one angle, suppose we know only angle 1, that suppose that is 100 degree. Okay, angle 1 is 100 degree. there are remaining 7 angles, that is angle 2, 3, 4, 5, 6, 7 and 8. We have to find all these 7 angles. Out of 8 angles, we only know one angle, measure of one angle, that is 100 degree. We have to find out all the remaining 7 angles. Now how are we going to find 7 angles out of 8 angles? Yes, we have a solution. We can use any relation. We have 6 relations. First one is linear pair of angles. Second is vertically opposite angles. Third one is corresponding angles. Fourth one is alternate interior angles. Fifth one is alternate exterior angles. And sixth and latest was co-interior angles. We will try to use these relations in order to find the remaining 7 angles. We will use these relations. Yes. Some may use a linear pair of angles, and some may use vertically opposite angles. It depends upon how we think which relation is suitable. One may use one of the relation and another student may use another relation. It depends upon how we think. Let us see. Angle 1 100 degree, and angle 2. We have to find angle 2. Now what is the relation between angle 1 and 2? If we know the relation between angle 1 and 2, definitely we are going to find out this angle 2. Now what is this relation? What is the relation between angle 1 and 2? Do we know? Yes, definitely we know. These form a linear pair of angles, isn't it? Angle 1 and angle 2, they form a linear pair of angles. So we can take as, for example, solution 100 degree plus angle 2, their sum is 180 degree, isn't it? Their sum is 180. Why? Because these form a linear pair action, linear pair of angles. Let us see. Angle 2 is equal to 180 degree. This will become minus 100 degree. So we will get angle 2 is equal to 180 minus 100, that is 80 degree. So we have found angle 2 as 80 degree. Angle 2 is 80 degree. Now we will find out angle 3. Again we can use the linear pair of angles. To find out angle 3, we can use linear pair of angles because their sum is 180. But we should also know that angle 3 is equal to angle 1. These are vertically opposite angles. We have discussed about this relation. Angle 1 and angle 3, these are equal because these are vertically opposite angles. When two lines intersect, vertically opposite angles are equal. So angle 3 is equal to angle 1, or angle 1 is 100 degree. So we can write angle 3 is equal to 100 degree. Angle 3 is equal to 100 degree because these are vertically opposite angles. Vertically opposite angles. Okay, now after this we will find angle 4. We can use the relation that is linear pair of angles here. But angle 4 is equal to angle 2. We know angle 4 is equal to angle 2, isn't it? Angle 4 is equal to angle 2, but angle 2 has been found out to be 80 degree, isn't it? 80 degree. Why are these equal? Why is angle 4 equal to angle 2? Why is angle 4 equal to angle 2? Because these are vertically opposite angles. Vertically opposite angles. Okay? And angle 2 is 80 degree. We already know it. Now that implies angle 4 is equal to 80 degree. So we have found out angle 2, angle 3, angle 4. Now angle 5. See. Now angle 5. We have to find out angle 5. we know angle 3, then we can find out angle 5 as well, because these are alternate interior angles and these are equal. Alternate interior angles are equal and these two lines are parallel. So we can say that angle 5 is equal to angle 3, isn't it? And angle 3 has been calculated as 100 degree. Why are these equal? Why is angle 5 equal to angle 3? Because these are alternate interior angles. Okay, alternate interior angles. Now angle 5 has been calculated. Now angle 6. Now angle 6. Do we know that angle 6 is equal to angle 4? Yes, these are alternate interior angles. In angle 4 we already know it is 80 degree. So we can write angle 6 is equal to angle 4. Angle 4 is equal to 80 degree. Why are these equal? Why is angle 6 angle 4 equal to angle 4? Why is angle 6 equal to angle 4? Because these are alternate interior angles. Alternate interior angles. I am writing the short form of alternate interior angles. Now angle 6 has been calculated. Now we will calculate angle 7. Now angle 7. Do we know that angle 7 plus angle 6 is equal to 180 degree? Yes, because these form a linear pair of angles. We know angle 6, we can find out angle 7 by using linear pair of angles. But we also know that angle 7 is equal to angle 5. Angle 7 is equal to angle 5. Isn't it? Why? These are vertically opposite angles. And angle 5 has been calculated. Angle 5 has been calculated. We can write here angle 5 is equal to 100 degree. So angle 7 is equal to angle 5 and angle 5 is equal to 100 degree. Why are these equal? Why is angle 7 equal to angle 5? Why is angle 7 equal to angle 5? Vertically opposite angle. We can write here vertically opposite angles. And we can write here angle 7 is equal to 100 degree. Now is the last one. After angle 7 we have to find out angle 8, and angle 8 is equal to angle 6. Or we can say angle 8 plus angle 7 is equal to 180 degree, because these form a linear pair of angles. But the best way to find out angle 8 is that angle 8 is equal to angle 6. 8 is equal to angle 6, and angle 6 has been calculated 80 degree. Now why are these angle 8 and angle 6 equal? Why? These are vertically opposite angles. And we get angle 8 is equal to 80 degree. Hence we have found all the remaining 7 angles. We knew only one angle, that is 100 degree, and we had to find out the remaining 7 angles formed here, and we use it here. We use it linear pair of angles. We use it vertically opposite angles, and also one of the relations alternate interior angles. Okay, this is how we have found out the remaining 7 angles. Okay, now in our next lecture, that will be lecture number 8, we will have a discussion about axioms and theorems. Thank you very much for now.